Okay, page 2, the top of page 2 for 10.1. Let's look at now some more examples, but let's look at what's different about these. We've been taking the plus or minus square root of both sides to be able to get the squared piece alone, and this time what's different is the squared piece is a binomial. It's y plus 7 instead of just y squared. It's y plus 7 squared. Now, in chapter 7, what we would have done with both 28 and 34 would have been to move the number over, get it equal to 0, multiply this out and combine like terms, then try to factor. But what we're going to look at now is what we can do in case it doesn't factor, and in fact the square root property can help with some of those. So let's look at number 28 here. And again, we're building up to the quadratic formula, which can be used no matter what. You won't even have to stop and wonder, is it factorable, is it not, which one should I use? When we get to the test, if you like the quadratic formula, you can use it for all of these. But as always, you can pick and choose based on your preferences, your speed, your efficiency, whatever your strategy is. But let's look at what the square root property would look like. Again, the first step is to get the squared piece alone. That's here in the middle of your page. That's step 1. I think that's in view of the camera. Yeah, the steps are in view of the camera. And we're going to start by taking the plus or minus square root of both sides. So we've got y plus 7 quantity squared equals 5, and we're going to take the plus or minus square root. Because the squared piece was already by itself on one side, we're going to undo that with the plus or minus square root. And so that makes the square piece go away. That's all it does. It just frees up that whatever was under the radical, the y plus 7. And over here we get plus or minus radical 5. This can't be simplified, the plus or minus radical 5. It is a irrational number. It has a decimal that goes on forever. So keeping it in its radical form is our best bet. And now we go back to what we would normally do trying to solve for y. We get it by itself. By undoing what's happening to it, we subtract 7 from both sides. Again, resist going straight to the calculator here. You want to learn how to put this in what you'll come to know this as a complex number, where it has a radical piece, or not a complex, but a mixed here, because when we get to imaginary, you'll want this radical piece and the real number separate. But you'll just write this as -7 plus or minus radical 5. So we don't go to the calculator, we don't try to make this into a decimal. This is the simplified version of this, -7 plus or minus radical 5. Make sure that plus or minus, which means there's two solutions here. There's -7 plus radical 5, and there's -7 minus radical 5. So those are those two solutions. Let's look at number 34. Again, what's different about this one? Well, you've got the x squared piece, and you've got the x piece involved. It's got that quadratic field to it, ax squared plus bx plus c. Again, normally what we do is before today, what we would do is subtract the 49 and get x squared minus 6x minus 40 equals 0, standard form, and then try to factor. And then you could mess around with -40 until you got a combination that gave you -6. This one is factorable, but I wanted to show you another way to deal with this in terms of the square root property. And the square root property says that if you can get it into something squared, then you can take the plus or minus square root of both sides. So this is actually a perfect square trinomial. So if you look at the x squared minus 6x plus 9, it can actually be factored into x minus 3 times x minus 3. And the reason why I'm interested in doing that is because the 49 is a perfect square as well. So this can be written as x minus 3 quantity squared is equal to 49, or 7 squared. We'll just leave it as 49 for now, but then here I've got a squared piece all by itself, even though the piece has more going on inside of it. It is a squared piece, and we can take the plus or minus square root of both sides to solve. Again, it's not the only way to do this. It's just a way to look at it so you can see what your options are, and then as we go on through this chapter, we'll investigate what is the way that solves all of these, whether they're factorable or not. So you take the plus or minus square root of both sides, and it undoes the square. So this is now taken care of. That it just undoes it. So it doesn't do anything to the inside, just releases it out into the wild, so to speak. X minus 3 is equal to plus or minus radical 49 is plus or minus 7. And then as you solve this, you're going to be adding 3 to both sides. You've got two different solutions here. You've got positive 7 plus 3, and you have the negative 7 plus 3. So our answers here are x is equal to 7 plus 3 is 10, negative 7 plus 3 is negative 4. So you have two different answers here. You could write that in set notation to show that they go together in one set. Both of those work in this equation. And when they turn out to be nice numbers, in like over here, negative 7 plus or minus radical 5, those are not nice numbers. Those end up being really pretty ugly decimals. But if they turn out to be nice numbers, even fractions, where you have rational numbers, these are irrational because of the radical 5. When it turns out to be rational numbers, that's a little kind of hindsight look at, oh, this would have been factorable. We could have moved the 49 over, got negative 40. We could have used factors of x minus 10, x plus 4. We would have gotten our positive 10 and our negative 4 out of that using the zero product property. But that's not the point. The point is to practice the square root property during this section so we get a feeling for what that is, because we're going to be able to use that then to do the 10.2 bonus. It's an optional section where we learn about how to complete the square, and then that will lead us to being able to discover, in quotes there, being able to recreate the quadratic formula, which works to solve any quadratic, factorable or not, square root property or not. So that's where we're headed. Okay, so take a moment to talk things through. Again, note on the steps here, it didn't print on my page. I don't know if it'll print for you, but it's supposed to be an x squared or a parentheses squared. Get the squared piece all by itself, take the plus or minus square root of both sides, and then simplify and rationalize. Talk this through, note any questions that you want to bring to class, and then try number 24 here. Pause the video and come back to check your answer. And this one, once you do it, it turns out to be negative 4 and 3 are your two solutions. X equals negative 4, x equals 3. You can write them as a solution set using the French, they're not really French, braces here to show that there's two possible answers. And then at the bottom of the page is a little bit of a reminder there from page 600 of what the square root property is. And a little typo there, should have just been a single p per page. Page 600. We'll walk you through that. And then on to page 3.